Hey guys, so today we are going to be working on our test review. So let's go ahead and jump right in. For our very first question, it says to graph our following functions. So what we need to do is first, we need to figure out what our asymptote is. And remember, it is whatever is added or subtracted from our function. So let's zoom in a little bit. So our equation is y equals 1/2 to the x. So then our asymptote is going to be 0 because there is nothing added or subtracted from our asymptote. So we're going to put our dashed line, which you can almost see, right on top of our x-intercept, or x-axis, excuse me. And then we need to make a table of values. So remember, we need to use our calculator and we're going to press the table button. Okay, remember that was this button here. And then we're going to enter in our function exactly as we see it. So we have 1/2, and then this is our to the button, our exponent button, and it's exponent of x, and we press enter, and then we're going to press enter a whole bunch of times, and then we're going to scroll up until we get to our topmost point that we can graph on a graph. So we're going to make our table of values. We have our x and our y, and then we have -3, 8, -2, 4, -1, 2, and 0, 1, and 1, 1/2. Alrighty, so all I did was get these numbers from our table of values over here. Alrighty, so now we can go ahead and graph them. So we have -3, so -1, -2, -3, and then 8, so we're going to go up 8, which is going to be right here, and then -2, 4, -1, 2, 0, 1, and then 1, 1/2. Alrighty, so don't need that for right now. So now we are going to connect our dots. So we have this curve, and then we just make it really close to our asymptote, but never touching our crossing and our arrows. Alright, so we just graphed our first one, so now let's answer the questions about it. So we're going to zoom out. Alrighty, so is this a growth or decay function? This is growth. But why is it growth? Oh, I'm sorry, it's decay. I was not paying attention. This is decay. Why is it decay? Because it's decreasing. Our graph is decreasing. And then looking at our equation, our b value is 1/2. So our b is less than 1. Okay? Alrighty. Now let's take a look at our asymptote. What's our asymptote? Our asymptote is 0. But can we just put 0? No. We have to put y equals 0. And then our domain is all real numbers. And another way to write all real numbers is -infinity to +infinity. And then our range, remember, it's always going to be y. It's always going to be our asymptote value. And then we just have to look at our graph. Is our graph above or below our asymptote? It's above it, so y is going to be greater than. Then we're going to determine our y-intercept, which is where it crosses the y-axis. And it crosses right here at 0, 1. So y equals 1, or, okay. And then our x-intercept is where it crosses the x-axis. Do we have one? No, we don't have one because we have an asymptote at 0. Alrighty, so now we are going to look at number 2. Same type of deal. Only this time our asymptote is 2. So we're going to draw our line at 2. And then using our calculator, we are going to press the table function. We're going to clear that out. And then we're going to do 3 to the, whoops, that's x squared. 3 to the x, and then plus 2. And then we're going to start it, press OK. And then we have the point 0.03, 1.5, and 2.11. Alrighty. So then we can plot those points. So 0.3, 1, 2, 3, 1.5, 3, 4, 5, and then 2.11 is going to be about right here. Okay, alrighty. And so then we're going to connect our dots. There we go. And we just graphed it. So now, do I have a growth or decay? This time I have a growth because we are increasing. And our b is 3. So our b is greater than 1. All right. Our asymptote is y equals 2. What's our domain? All real numbers. Or you can say negative infinity to positive. Our range is y. It's the value of our asymptote. And then is our graph above or below our asymptote? It's above it. So y is greater than. Then our y-intercept, where it crosses the y-axis, is y equals 3, or 0, 3 for that point. And then, do we have an x-intercept? No, we don't, because of our asymptote at y equals 2. So the only time we are going to have an x-intercept is when our asymptote is a negative number. Alrighty. Okay, so we just did the first two problems. So now let's move on to number 3. So number 3 wants us to write an equation for the following. So remember, whenever we write an equation, it's going to be in the form y equals a times b to the x, where a is our initial value, and b is our multiplier. It's our base. So then, looking at this table of values, what's our initial value? It's when x equals 0. So then, our a is going to be 6. Alright, and then we need to figure out our b. So 2 times what value is going to give us 6? That's 3. We're going to multiply by 3. And then 6 times 3 gives us 18, and 18 times 3 gives us 54. So our base is going to be 3. So then our equation is going to be y equals 6 times 3 to the x. Alrighty. So now let's take a look at our graph. For this one, we actually have to plot some points. So we have the point negative 340, we have negative 220, we have negative 110, we have 0, 5. So let's make a table of values using those pretty points. Alrighty. So 40 times what gives us 20? If you are not good at fractions, go ahead and type it into your calculator. So we are going to start at our bottom and do 5 divided by 10. And that gives us 0.5. So try it. 40 times 0.5 gives us 20. Awesome. So we know that when we multiply 40 times 0.5, it gives us 20. So then let's try it again. 20 times 0.5 gives us 10. Good. And then 10 times 0.5 gives us 5. So each time we are multiplying by 0.5. And then what was our initial value? That was when x equals 0. So then our a is 5. And our b, we said, was 0.5. So then our equation is y equals 5 times 0.5 to the x. Excellent. Doing okay? All right, if you're not doing good, take a moment, rewatch this video. Alrighty, so now we are on the second page, and y'all are going to tell me what your y equals when x equals 0. That's that first question. This is just another way to say x equals 0, so y equals what? Well, that's just our y-intercept, which is 100. Okay, so now I want you guys to answer these questions. So first, tell me, is it a growth or a decay? Alrighty, so hopefully you said this was a decay. So now, tell me, whoops, sorry guys, what is your asymptote? You should have said that your asymptote is y equals 20. And then, let's take a look at our range. Tell me what your range is. Hopefully you said that your range is y is greater than 20. And then everybody knows our domain, so what's my domain? That's right, it is all real numbers. Or you could have said negative infinity to positive infinity. Okay, and then finally, my y-intercept is what value? Well, we kind of already answered this one. It's y equals 100 or 0, 100. These two questions were exactly the same. Alright, so hopefully that helped you all out in understanding and being able to determine our growth decay, our asymptote, our range, our domain, and our y-intercept. So let's move on to number 11, where an investment of $200 earns 5% each year. How much will it earn after 8 years? So we have to determine if this is growth, decay, or compounded. What do you think? I'm hoping you said it's growth because it's a growth function. And the reason why is because it says earns, and it does not say compounded. So what is your A value? Your A is your initial value, so that's going to be 200. And then your rate is 0.05, and your time is 8 years. So the equation we're going to use is y equals a 1 plus r to the t. So all we have to do now is put that into our formula. So y equals 200, 1 plus 0.05 to the 8th. And now we're going to type that into our calculator, exactly as we see it. So I have 200, parentheses, 1 plus 0.05 to the 8th, and that gives us $295.49. All Alrighty, so that's how much it earns after 8 years. Doing okay? Alrighty, let's take a look at the next one. The price of a new car was $18,000 in 2010. The value of the car depreciates at a rate of 15% every year. Write the function to show how much the car will be worth after X years. How much is the car worth now? Alrighty, so first, is this growth or decay? It's decay because it says depreciates. So when we do decay, this is going to be the y equals a, 1 minus our r to the t. So what was our initial value? It was 18,000. And then our rate was 0.15, and then our t. So our t is a little bit tricky because we started in 2010 and it wants its worth now. Well, when is now? Now is 2019. So how many years were in between 2010 and 2019? There were 9 of them. Good. So now we can do our equation. And then we can type it into our calculator. And we get $4,169.11. So that's how much the car is worth now. Sorry, this is supposed to be a dollar sign. There we go. Alrighty, let's try the next one. So the number of bacteria in a petri dish triples every hour. If your initial population was 5, write a function to represent the number of bacteria after X hours. And how much bacteria was in the petri dish after 6 hours. So what does triple mean? What do we multiply by when we say triple? We multiply by 3. So since we're multiplying by 3 every time, this means that our base is 3. And it says our initial population was 5. So that means our A is 5. So this one is going to be in the form of y equals A times B to the x, which is just going to be y equals 5 times 3. And then our time was 6 hours to the 6th. Okay? You will note that it's going to be one of these because it's going to say triples or doubles or halves. That's when you use this equation. So type it into our calculator. We have 5 parentheses 3 to the 6th, and that will give us 3,645. Doing okay? Alrighty, let's take a look at 14. So 14, that is 15, I need 14, there we go. Sophie invested $5,000 into an account that will increase by 2.3% each year. Write a function to model the situation, then find the value of the investment after 15 years. So you guys go right on ahead and try this one, okay? So I want this answer. Okay. So your equation should have been a growth function. And it should have been y equals 5,000, 1 plus 0.023, and then to the 15. And then when you type that into your calculator, you will get $7,032.42. Good. Alrighty. So now we're on to 15. A baseball card that was valued at $200 in 1980 has increased in value by 7% each year. So we're going to write a function to model this equation and then find the value of the card in 2016. So let's work this one together. So this is going to be a growth. So we're going to have y equals a 1 plus r to the t. So then our a is going to be 200. Our rate is going to be 0.07. And our t, well, it started in 1980, and we want to know the value in 2016. So we are going to do 2016 minus 1980. And that's going to give us 36. So that's going to be our time. So then we're just going to substitute all of this information in. And then we're going to use our calculator. To get $2,284.79. Good. Alrighty, for 16, Miles invested $2,400 into a retirement account that earns 1.8% interest compounded monthly. Write a function to model this situation and find the balance of the account after 25 years. So we have a very important word here. It's compounded. So that means we are going to use our compounded equation. So we have A equals P 1 plus R over N to the T times N. Alrighty. So then, our P is another word for our initial value. What's our initial value? 2,400. Our rate is 1.8%, so that means it's going to be 0.018. Our T is 25 years, and then our N is the word that comes after compounded. So there are 12 months in a year, so our N is going to be 12. And then we're just going to substitute this information into this equation. And then we're just going to type it into our calculator. Let's see. Make sure we can actually see our calculator. And that will give us 3,762.68. Okay. And again, that's dollars. Alrighty, so now I want you guys to try 17. Okay? So you guys try 17 right now. Alrighty. So for this one, our equation should have been 30,000, 1 plus 0.04 over 4, and then 4 times 12. And then when we put that into our calculator, we should get $48,366.78. Alrighty, and that is our test review. So good luck on your test, guys.